Recording in progress.
Hello, thank you for joining today. Today we are going to start our lecture, which is going to be on creating baseline models, model for regression problems. So this is going to be our today's topic, and thank you for joining. And if you do have some contact with your colleagues, just let them know that we are having a session right now, and then we are going to start. So the goal of today is it's all about acquire the prerequisite knowledge to solve problem 1 for sprint machine learning scratch linear regression. So this is the link that we are going to be using, and I'm going to share it with you so that you can be able to see what we are going to do. So if I remember, yesterday was I just shared with you this link, and then I asked you to just have a review and then read about it, and then if you do have some questions, just write them out, those questions, and then I'll be answering those questions. So now let's proceed with our topic. So we've seen what is Scratch, what is Runia, and then now we've seen how we can check Runia regressions. So now we are going to start to create like a linear regression function which can be used in machine learning Scratch, and then you will be able to deal with any problems which might be related to linear regressions. So there is what we ask ourselves, like if you are going to just run this knowledge of how you can solve sprint machine learning scratch linear regressions, the first thing that you need to know like what is a function first of a linear regression. So in the function for linear regression, we do have this what we call hypothetical function. So they say that in many cases, like the objective of explanatory variables are going to be simple, rational expression, and also they are not going to be not always match exactly to what you are looking for. And then in this case, like it's going to have some figures below. So they say that sometimes it's possible to just approximate with straight line. There's no straight line which is exactly matched without error. So like if you are going to use this straight line, sometimes it might give you the wrong answer. That is what I can say, because remember that what it's going to do, it's going to just divide it into two, and then it moves on. So now we do have what we call human hypothetically defines a function, which is going to be equation that the data will approximately follow. So it's going to be hypothetical function. This hypothetical function is going to be more likely to have a relationship between variables. We will be clear at time. The data is going to be given, and also in general, it is necessary to consider what variable are being analyzed and how they are affected, and we are going to be having some modeling, which is going to be showing the relationship between the variable you obtained by just showing it in the diagram, and then the function that itself is going to be called a model. Just once you're going to show it on the diagram, just trying to model it, it's going to just be called a model, and then the that function, hypothetical function, is going to be said, the ones which is going to be expressing the model, like how the model is doing on the model, like it's going to now show it on the graph or on a diagram, and then it's going to show you how it's just performing. We do have this hypothetical function, which is going to be like this. As we said, this hypothetical function is going to be checking the relationship between variables obtained by modeling, which is going to be shown in diagram, and then also the function itself is going to be called model. So this hypothetical function can be said to be one mean of the expressing the model. So for example, you might say like this is a hypothetical function, and then it's having the summation of the number that you are having, which is going to be equal to the variable we obtained, and then we are going to take the summation of it, and then it's going to be the initial one. The initial variables is going to be equal to 1, and then it's going to be having multiple regressions using these explanatory variables. So this is how it's going to be. So once you check, I hope the screen is clear enough to see there is no issue. So once you check this function, which is going to be the expression is going to be the equivalent to the simple regression expression, which is going to be like this regression expression is having these variables. For example, ix1 plus b, which is going to be mentioned in the previous chapter. So the above equation can be written in the following form, involving the inner product of the vectors. Using the real vector, it can have theta, which is going to be using just a function of theta, which is going to have the length of the variable that we have defined here above. And then in the period, it's going to be having expression means that the end of expression is going to have the means of the end of expression, and it has not affected at all the statement by it's omitted. So this is what we have in the set theta, which is going to be unknown, equal to theta multiply unknown variables that you are going to have. So with this formula, it might be a bit complicated, but once you apply it into the real function, you're going to get how it's being used. Okay, so now we are going to calculate y without using the inner product. So to calculate y, we are going to use this formula. I can say formula where we say y is going to be equal to ax1 plus b. Okay, let me share the link again. Yeah, that is the link that we are using right now. So as you've seen, we are going to say like ax, a multiply x plus b without using just any product, and then we are going to print out the y. So we do have a, it has been initialized to 1. We do have b equal to 2. We do have x1 equal to 3. So once we check the product, once we check the this implementation by using the inner product, we say that y is going to be equal to a multiply x1 plus b. So this is the formula that we are going to use, and then print y. So you are going to copy this. Comment. So now you can see, we are going to have, you are going to have a 5. So once you check, if we take 1 multiply 3 plus b, 1 multiply 3 is going to be 1, and then plus b equal to 2. It means 2, 3 plus 2 is going to be 5. So can you try to do it on your end and we see? Hope we are going to get the same result. Okay, all right. So after this, the next we are going to confirm that the inner product is going to be calculated, and then the result must be 5. And then in Python you can use once you use this USD dollar or art, or just it means that you are going to calculate the inner product, which is going to be having the equivalence processing, can be performed by setting the part corresponding to this b as the first component, and then the other component is going to be theta, and then setting the first component is going to be the input. So this is what we are going to do the next, equal to numpy.array of the b and a. We have declared a and b values which are assigned to them, and then we do have x equal to np.array of this, and then we say that it's going to be picking the first one and the second value that we are having, and then it's going to print theta and then print y. So let's see if the theta is going to give the same result as we used for the inner product. So you are going to copy this code and then paste them here. And then we are going to check. So you see, it can just give 5, as we got 5 here. So you can use theta. Theta can be also performed the same thing, as long as you say that theta is going to be checking a and b, this one, multiplication. And then once x is going to be checking the array of the first one, this multiply this, which we've said that it's going to be 3. x1 is 3. The first one is going to be 1 multiply this, and then once you take x multiply theta, theta will say that it's going to be taking b and 3, and then it's going to return out 5. So do you have some questions on this? How to use theta?
If possible, can you come again? Can you explain the code again, please?
Yes. Yeah, here on inner product, we just initialized, or we declare the values which are going to be assigned to a, b, x, y. And then the initial part for y, we say that y is going to be using this formula. This is the formula that we are going to use without using the inner product. So once you use this product, it means it's going to be a multiply x plus b. That is it. A multiply x, a multiply 3 plus b. That is the formula. And then on this part, what we are going to do, we are going to be checking we're going to have the inner product, which is going to be matching. For this, where we said y equal to a multiply x plus b. And then now, because there is many ways you can do it, we are going to just change it instead of checking the first component by saying that y equal to this. We are going to use theta by having the first values, which are going to be assigned to these arrays. So b and a, we know b and a what it is, and then we are going to take x. X is going to be equal to our array that we are having, which is going to be the first one, and then the rest one we have. So the rest one we have is going to be x1, and it's going to do the multiplication. So once you check the y, it's going to be taking this x, this one, multiply this one. So this is going to be multiplied the above one. So, and then once you print, it's going to still give you the 5, but in the form of arrays, because we say that theta is going to be checking the arrays of the b and a, and also x is going to be checking the arrays of the first variables with the indexes that we are going to use, and then it's going to be printing out.
All right, thank you.
Do you get it?
Yes.
Okay, all right. Yeah, thank you for asking. If you do have other questions, just feel free to ask. Okay. So now, here they try to give some explanations which are well understandable, because they say that to be able to use inner product with explanatory variables rec x and theta, you need to just match the columns. So once we check the columns of the previous matrix, the two matrices to be inner product with the rows and the second matrix. So we shape with shape, and then we print x shape. So we get 1, 2 by checking. Once you check the shape of it, of the x, if you check the also the shape of this, you're going to get 1, 2, 2, 1. And then once you check the theta of it, it's going to be, once you print the theta shape, it's going to have this 2, 1. And then it means that it's going to have 2, 1 y, once we check the y, it's going to be having 2, 1, 2, 1, 2, 2, 2, 1, which is normal computation since the quorum of the previous matrix and the rows of the second matrix match. So now in the another words, the y's are going to be theta, but the functions are shown function of linear regression. So it was confirmed that one above can be replaced with two using expression of the inner product. So to keep in mind, that is notation is going to be commonly used. So now we are going to be having the function implementation, which is going to be like we are going to try to run the implemented hypothetical function with the generated theta, like where we do have x as an argument, and then in the following example, the hypothetical function is going to be defined as linear hypothesis, and then the single underscore in front of the function indicates that the function is used only within the class. And then it is commonly practice to add in underscore to functions used only within the class to improve program readability. And then in the program one, it is not necessary like to incorporate the function into the class, but if you want to incorporate it into a class to complete Scratch class for linear regression, you just give it a self as the first argument. So we do have this linear hypothesis, and then we do have this is the first function that we are going to create. So it's going to have the function which is going to be linear hypothesis, which is going to be taking an explanatory variables x as an argument, and then the first arguments are self-specified that that is a member function, and then here we can calculate just output or assumed function parameters, where we check docstring return function description. Up to here, like you check x is going to be following from number of arrays, shape, some number of samples, sample features, training data, and then it's going to returns. So of the following from number of arrays, shape, number of shapes, it's going to be estimated result by linear hypothetical function. And then it's going to be having this x as a self theta, and then it's going to be returning the prediction. So we are going to have a function definition which is going to take explanatory variables as x arguments. The first argument is going to be specified. This is function is going to be a member of just this. So we can just copy this, but it has nothing. Just it's going to return out the value for the predictions that we did. What we are going to do, we are going to the next page, which is going to give more explanations on this. As you can see, it's just returning nothing, but you can just print out the predictions. So do you have questions on that? No questions. So let me share the link, or you can click on the next part. Try to open the shared link. So we are going to be checking what is the steepest descent method of linear regressions. So we do have this machine learning scratch understand the knowledge required to solve problem 2. That was the first one was for linear regression problem, and then the second one is going to be machine learning scratch of the linear regression, but this is going to be the steepest descent. You've been just operating some thing like this, but now we are going to be checking, like in the previous text, we introduced how to solve regression equation, means finding the best value. And then this section explains how to find the theta. And then with this, we are going to be checking. Yesterday, we were checking like how to check the mean squared error. How are we going to just be able to recognize like this is not working as expected? So now we are going to start with the error. So the best way to just have the best fit to the data, we are going to generally define as the smallest average of the sum of the squares of the differences between the predicted and true values. So the difference between the predicted value and true value is going to be called error. So if you find this you are going to see it on the graph and then you are going to understand. So, and then the average of the sum of the square is going to be called mean squared error, which we've seen yesterday. So now, if you are going to check the difference between like, this is the linear regression, like line. So if you check the distance, is it a distance or difference between the predicted value and the true value? This is the predicted value, it's here, and then the true value is should be here. So if you check the distance or the difference between the predicted value with the true value, this is going to be called the error. So instead of being straight instead of being straight like this, at least this, it's just in this way. So which is not good, because you can see it's just getting no value. So now once you are going to be checking the error, you are going to check what has been predicted to what to the true values, and then you are going to get the sum of uh squared error, which is going to be the mean squared error. So that is how it's going to be look like. And then it's going to be often used as a goodness of it matters because it's easy to implement. So to just have mean squared error, how it has been used. So they use theta, which is going to be the value of the data that you are going to have, 1/m of the summation of the values you are having, where the I is going to be initialized to 1, and then the index data theta of the unknown data that you're having minus the true values, and then squared. So that is how it's going to be, and then the wall is just of the steepest descent method to find the theta such that the value of the equation is going to be minimized. So now we are going to be checking the steepest descent method, how to find it. So we do have the linear regression where horizontal axis is going to be having theta, and then the vertical axis is going to be having mean squared error. The function draws a parabola to explain why it's the parabola. Simple regression equation is going to be having xy plus b, which is going to be substituted to the these theta variables. We are how to find the theta. Like now, this is going to be the descent method. So you do the same thing as you did above for finding the mean squared error. After finding the mean squared error of this, the next part you are going to find the steepest descent. Once I say the steepest descent, like how far this line should be, like instead of going far from the true value, how far it can be closer to the true values. So that is what we are trying to do. And then once you do something like that, you see now you can see there is a equation which is going to be an just a quadratic function that is convex downwards for parameters a and b. And then with those plots, the equation for the mean squared error with R on vertical axis is going to be theta. On the horizontal axis, we see that it will look like the following figure. So originally, we don't know the shape of overall the mean squared. So that is it, and you can see that the point where the value at the mean squared error is going to be the smallest. So if you check, instead of having that straight line, now we do have something called a quadratic, which is going to be more of downwards for the parameters of A and B. So if you check, it's more um, having a shape compared to the straight line we used to have. And then after this, we can see that the point where the value of a mean squared error is going to be the smallest at this point, and then the optimum value is going to be here where there is a star. This is where we can find the optimum solution, because the optimum solution is going to be like the point where the mean squared error is going to be at to the point, like this is where the mean squared, the error is going to be on the minimum point. So if you check, I'll ask you to check for a moment this. If you check this straight line here we got, if you do have that quadratic, you can see it's going to be like the same as here. This is where the star is. So this is where the minimum point of small mean squared error is, and then it's going to be displayed. So now we are going to be checking how to calculate mean squared error, find slope of random plotted position where we do have this, we do have slope, which is going to have distance like this. If you check, now we are going to check the harimo umuntu hari umuntu wabukinze. Sorry for distraction. So if you check to find the minimum mean squared error, so this is a quadratic we are having, and then we do have this, and then for checking we do have this. We are going to check the distance between this theta to over this, which is going to be equal to this one. And then as you can see, this is the initial one, which is going to be starting here. Like if you check the distance from here to here, what are you going to get? So so it means that we are going to update the value of theta based on the slope gradient of the running rate. So now the first, which we find the slope randomly, just plotted theta and the position, and then we are going to be having the update value of the theta based on the slope gradient and running rate. So now we do have the odd one. This is the first one that we are having. Once we are going to just find the theta, the old one, and then this is the new one. So if you check the distance from here up to here, and then you check the other one, so you see the small the short distance is going to be the second one. So now it means we are trying to update the value of theta based on the slope gradient and also based on the running rate. How far is it going to be used? And then we check once more. We repeat until the theta value converge sufficiently. So now we are going down. We are going down, 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 up we reach to this extent, like we feel like we don't need to go deep down. So that is how it goes down downwards, and then it's going to find the minimum. And then now the next part is how to calculate the expression of the function, and also to find the slope of the gradient that we are going to have. So we do have theta, the first one, which is going to be 1 over the distance that we are having of the summation that we are having, minus the second one, the second distance over here. And then we continue, we start to the first one, to starting to here, and then do the same thing minus the third one, and then do the next thing up to you reach to this slope. And then after reaching to this slope, this is when you are going to be able to compute the way you feel like the linear regression coefficients is going to have this theta function, which is going to give you the equation, which is going to be updated. So this is the final one that you are going to have. It's going to have a theta of the function of the new slope, or for the new function that you are going to have, which is going to be taking the old theta, or the old slope that you are having, minus the alpha, the starting one that we are having over the next slope, and then it's going to do the minus to the newest one. The newest one is the one which is a bit close to the coefficients, and then this is the formula that we are going to have. So questions on this?
Mentor Amina, when so basically we are trying to find the part of the graph that, in this case, is the minimum part of the graph uh, the, that has minimum error, right?
Yeah,
When performing this uh,
yeah,
the derivative.
yeah, that is what we are doing, but we are doing it based on I can say the distance or the running rate, because we start with the high, we try to find the minimum based on I can say the distance of the center. Is it I can say center of gravity, because the more you go down, the more you are going to reach to this
Yes.
optimal solution.
Oh, okay. Yes. Yes.
Yeah. All right. Do we have questions on this?
Mentor, another thing. So you're saying that the optimal
Mm,
solution is not uh, is not entirely achieved. It's like we trying to get to the optimum, but we don't reach. Is that
yeah.
right, or do we
Yes.
have like the formula take us to the optimum?
100%. It's not going to be the correct one, because linear regression, most of the time, it's not going to give you the exact answer, like, but it's going to give you the a close right answer to the expected one. So if you are just finding the minimum optimum solution, so based on the minimum squared error, uh so the first thing that you are going to check, if you check this, so this is where we are. This is like a house price, right? And then once you use a linear regression, it might this is an example that they are showing you. What if it predicts something like this? Are you going to get the solution?
No, you're not going to get.
Yeah. But if you are going to use linear regression, because you know that it's more of prediction, it's going to be you're going to use this quadratic, which is going to help you to find just not a right answer, but a bit closer to the right answer. So now once you use this, like we want, this is where it might be the solution. And then you want to reach to here, just instead of getting this like emptiness. So you can just use this steepest descent method, which is going to help you to find this it's going to eliminate all those unnecessary information. It's going to just get you closer to the answer, even if you are not going to get the exactly true answer, but it's going to help you this deepest descent. It's going to help you to just at least to have the right answer, because if you use this let me just use this as a graph, and then you are going to, yeah, for example, we do have this is going to be a quadratic graph, even if it's not going to be well well drawn. And then you are going to use that steepest descent. So if you use steepest descent, it might be like this, right? Instead of being this straight line. So though if you check the distance from here to here, you might feel like, yes, you can, even if you are not going to find the minimum squared error, but at this time you can find what you are looking for, because the most data are going to be based here, and then you are okay to use that data, and then you can get what you are looking for, because many people they are in that range. But for example, you don't have such a kind of data, but you need to have at least the sample data that you can use. So the first thing that you need to do, you need to avoid or eliminate unnecessary distance, which is going to be your eliminated, and then try to go up to your reach. So it's more of it doesn't mean that it's going to be like clustering just where it's going to be trying to pick where the element is, but it's more of trying to give you the partition of the answer that you are looking for by minimizing all unnecessary errors so that you can reach to your correct answer. So that is what it's going to do. It's going to help you to just go deep down and then try to get your result with in the easy way. That is how I can just explain it. So linear regression has formulas that you are going to see. There are many formulas you are going to just went through. But the ones you are going to use mostly is going to be this one for this equation where you just find the regression of coefficients of the theta, and then if you check, it's going to be applied here. And then you can be able to create a function for your own. So this is most of the time you are going to just use these functions in different problems that you are going to be solving. So you have to make sure that which function am I going to use, and which method am I going to apply with this kind of problem that I'm going to solve. So now to create let me just Reg, do you get the point before I proceed?
Yes, I got the point. I got the point. Maybe I just got a bit confused with data. But
Oh,
could you
but
like, yeah,
let me take you back. The data we had before, do you remember this? We had, it's going to be the same as multiplication, but it's going to be used in the form of arrays. Do you remember this? Once we did once we do inner product, we just say like we do have A,
yeah,
B, X, and then we want A. We say A is going to be A multiply X1 plus B. And then we said we can also try to use inner product but using the other function, which can be used as a theta. Like you can just you can have a corresponding the same as you did for inner product, but you can use theta. Theta is going to be used as a component which is going to have the same values that we have. It's going to do the same thing as you did for the product. So you can say theta np.array of these arrays that we are having. Remember that this is going to be picking the value of this and also of this, and then we say that x is going to be checking array of this value. Now it has the first one 1 and x1. X1 we say that it's going to be 3. So 1 multiply 3 equal to 3, right? And then once we say that we are going to be taking this, it's going to be taking this B and A. B and A is going to be it's going to be picking these values. So once you say x is going to y is going to be x of theta, it means now it's going to be taking the x theta is going to be taking 1 2. Yes, 1 2, that is for the x is going to be 1 2 because we say that yeah, it's going to be like that. And then at theta we've said that it's going to be 2 to 1. 2 to 1.
Yes.
Right? These are the it's going to be picking the indexes of these values that we have said, and then it's going to do the same multiplication. So which is going to be just it's going to be doing matrix. We know how to do matrix. It's going to pick the values that we are going to have, and then it's going to just take a 2 to 1, and then just 1 multiply 3 equal to 3, right? And then plus 1. This one is going to be multiplied to all product. Do you still remember how we used to do matrix? So the ones that this one is going to come, and then it's going to be multiplied to this and this, and also this one is going to come be multiplied to this and this. Let me just try to draw. So this is going to be to here and also here again, and also this is going to be coming here and here. That is what we did, right? And then once you check the y theta, it's going to give you the product, which is going to be 5. Do you get it?
Yeah, I got it. It makes more sense because it makes more sense to be linear. The name itself, linear regression. And
Once you
theta
understand, okay.
is the number that we take because of using a matrix. Yeah, it makes sense.
Okay. So
Yeah.
now once you go to the other part where we were for the theta, which is here, we said like it's going to be like the same case, like it's going to be taking theta as a function. It's going to take a new one, like to find the new slope. It's going to be taking the old one we have minus the second one based on to the optimum point that you are looking for. So there is nothing big which is going to be there. As you can see here, we do have a function called gradient descent. So to update this expression is going to be implemented using Python as follow. So the following function is going to be extracted from the component code. So the function does not work by itself. So if you want the following function to work by itself, you need to define it as a class definition and also adjust argument self. So the fourth line, that class, the function in the same class, self theta defined in the constructor, and so on. So now we are going to be checking the gradient descent. So the gradient descent function is going to have x and y. So x and y are going to be having m, like where it's going to be having the first shape and then the second shape, which is going to be n. And once you are going to do the prediction, it's going to have a self-linear hypothesis. Like this is going to be like it's going to be more of execution to compute the prediction. Like once you are going to do the prediction, what is it going to be predicting on the X? And then also a for loop that we are going to loop with the number of explanatory variables that we are going to have, which is going to be looks like this. And then we do have gradient, which is equal to 0. We do have for I in the range of M, we do have gradient plus equal to prediction minus Y I multiply X, which is going to be assigning, like the first thing that we are going to assign it to 0 to gradient. So the result calculation is going to be the summation of in the update formula, which is going to be here. And then with that range, we are going to be checking we are going to loop once more for the number of data that we are having, and then we predict the calculation of the summation of data that we are having, which is going to be calculated to be the final summation of our summation by value, making it gradient. And then we do have the summation gradient of the update formula has been calculated, and corresponding data is going to be in such a way. So that is how it's going to be look like. And then we are going to be checking the main goal. We are going to be checking the steepest descent. So methods which can find the values of parameters and to minimize the value, the output value of the objective function, and also try to update the equation derived by differentiating the mean squared error. And the image of steepest descent method is like descending through the mean squared error. So this is what we do. We are going to just copy the codes, and then we go to the next part. If you do have some questions, let me know. Yeah, this is how. Yes, Raj, do you have questions?
Yes, I just wanted to know about something about the code, like the part where it was written self data. Does it mean the sum of data in J?
Product. Yeah, as you see, we do have X and Y, which the ones we are going to use, and then we shape it. And here we said we are going to group the number of variables which are going to be used, and then to the gradient, and then to the steepest gradient that we are going to have. And we said gradient, initially we'll say that it's going to start to the point 0, and then we loop it to be like to having to the first shape that we are having, and then we predict based on the index that we are having of the product, which is here. And then once we say self dot theta, it means it's going to be checking the product of these variables that we have defined in this array that we are having for the X. If you remember that we said that M is going to be equal to X of this shape, and also N the same thing. And then the theta is going to be checking the product of it, of the J, where J, we've said that it's going to be grouped into, if you check here, they said that it's going to be grouped with the M number. So a number, sorry. This is where it's going to be roped in, and then which is going to be more of explanatory variables to be used. And then once you say the rest line here for theta j, it's going to be more of having the summation of gradient of the product we have calculated, and then it's going to be corresponding to theta, and then it's going to be used. So initially, yeah, if you check, yeah, we say that theta, we've seen how to check theta itself. The old one, which is going to be minus to the newest one, or the alpha or the next plot, with the summation of the variables that we are having, and then of the theta, and then minus to the optimum point that we are going to have. That is how it's going to be, and then it's going to be updating it based on that optimum value that we are having. But in theta in general, it's going to be this formula, this one. This is the ones it's going to be using. So it's going to be taking the summation, multiply the next point slot, and then minus the rest one. So this is the formula that they used. This formula, this is the ones which has been applied here. So
Yeah,
you,
it's clear. Yeah, it's clear. It's a bit, just a bit tough because of the math, I guess.
yeah,
But I got it. I got it now that you explained.
okay, all right. So is it okay with others? They are not talking. Ayrton, Jose, Iris, Ruiz, Alberto. Are we okay? Yeah, is it hard or complicated? Yeah,
No,
Iris
it's
is
not that
good.
hard. It's not that hard.
In my quiz, it's just extra attention, but it's not hard.
Yeah, true. Okay. Yeah, I know once you pay attention to this, once you understand first the formula, this is like the initial, or this is the basic of everything. So once you're going to work on steepest descent, whatever you are going to do, just you have to know this formula. And then by knowing the formula, it's not memorizing the formula, it's understanding how is it working. So what are you looking for? And then you are going to understand what you are going to be doing. So uh, if you check on this line 8, you see this line 8, they say that it's going to be having prediction minus y1, which is going to be like a calculation which has been done inside of the summation. So if you check this prediction to here, this is what we have up to here. So if you check where, this is what we have. So it's more of how to just perform what you are looking for, and also how you are going to make it. So if you know the problem, and it's going to be easier to know how to solve it. So now we are going to be checking how you evaluate regression estimation. So to evaluate regression estimation is going to be like not hard as to check the mean squared error in steepest descent, because this is going to be more of just a calculation, like what am I losing, what am I gaining. So with this machine learning Scratch, we understand the knowledge technique required to solve machine learning Scratch linear regression. We do have finding estimation, finding output value using parameters is called estimation prediction. We do have what we call this. Once you estimate, you can be able to do the prediction. So in problem 1, you have already implemented outputs of assumed function, but the function created in the problem 1 cannot be called from outside of the class. So now we are going to create a predict method, and it's going to have return a predicted value as a return value. So we do have this a function, the ones that we did earlier. So now we are going to create another function which is going to be predict. We are going to predict first. To predict, we are going to predict x, where x is it going to be relocated. So once you just do if self.bias equal to true, and then a bias is going to be like the first one, it's all about function definition. We are going to just do explanatory variables for x so that we can use instance self. And then we are going to call out once by the way, once you want to just use this variable outside of the function, always you need to use this keyword self. Once you just use instance self, is going to be called outside the function and can be used anywhere within the class. And we do have if self.bias equal to true, and then bias equal to np.ones of the x.shape dot reshape of the x. It's going to be shaping it to 0, 1, and then x equal to np dot hash star bias of the x, and then we do have predictions y equal to self dot linear hypothesis of the x, and then return y. After this, we do have what we call function definition, which is going to be argument as we receive definition of self of explanatory variables x so that we can use instance self. I've said it. Let me share the link here. Can we open the link? Oh, sorry, I forget to. Copy the code. Right. Are we together?
Yeah, hold on.
Okay. So, the last part was about estimation. just where you do prediction. And now we are going to be checking mean squared error for linear regression, the ones that we've seen in the previous, where we were just checking the steepest descent method of linear regression. And then now we are going to be checking mean squared. How is it going to be calculated itself? So we are going to just understand deep how to check mean squared error, and then how to implement mean squared error so that we can know what we are having, and be able to check like the difference between the correct and predicted value for each training data in the average of squared value called mean squared. So whenever we are going to be training, always we need to check how our model is doing. So we need to check the difference between the predicted value with the correct one. So that is going to be the mean squared error, which is going to show us how far are we going to reach to the correctness, which is always we want accuracy to be 100%. So this mean squared error is going to show us this is what we are looking for and this is what missing. So we do have this 1 theta, theta equal to 1 over m of the summation of this. And then in the set of theta is going to be having unknown variables minus the ones which have been predicted. So it's just the same thing we do. The corrected, the between correct, which is going to be unknown so far, but with the predicted. So we do have the predicted, which are well defined. And then this is how we check the mean squared error. We just take the difference between the correct and predicted value. So predicted value is this one squared. So this is how it's going to be. This is the formula. And then creating a functions. So the mean squared error defined above can be written using Python as follows. The variables appearing in the function should be considered as for us. So we do have a predicted value. We do have a correct value. So this is going to be the result of the mean squared calculation. So where we do have like mean squared, this is a function of it. So remember, we are going to find the correct difference between correct one and predicted value. So this is a predicted value, this is the correct one, y. So mean squared, it's going to be taking the predicted minus correct one squared 2 multiply sum of the variables that we are having of the shape of the input that we are having, and then return mean squared error. That this is the formula. This is the this formula is here in the code. This is the ones that we are having in the code. Question? No question? Okay, no question. So you can just copy it. I know by now you don't have question, but the more you go deep, you are going to just find some difficulties to understand this. So I know the more you read, the more you interact with it, you are going to just get some questions. So I would advise you to just do research on a linear regression series and try to understand it deep. I know there are some outsource brings which might give you more or clear explanations. That's how I can say it. And then you will understand what is so something. Yeah, regression in machine learning. So this is AI overview. Like in machine learning, they say that linear regression is going to be a statistical technique used to model the relationship between dependent variables on one or more independent variable, predicting continuous values. So this is a graph of it. So it's found the line surface multiple dimension. So they best fit data by minimizing the difference between the predicted value and actual values. So I think this one gives a bit explanation of it, and I'm going to show you the link you can visit, which gives more details. Hopefully it's going to be, where is it? Why? So you can use this analytics. Also I like it. It has, let me share it, the link. They do have these amazing explanations. I do use it sometimes, but the other ones allow for free. No. So you can just try to open it. Here they say that linear regression is a fundamental statistical method used just the same thing as AI given. But here they say that it's easy to interpret and apply. So it's going to help you to understand what is it. And once you talk about linear regression, you are going to be talking on dependent variables, the ones predicted and independent one, by finding the fit one. So this is what I wanted for you to check. The goal just to find the best rank that minimize difference between predicted and actual value. So once you do have this, you can see Y is going to be dependent variable output, X independent variable input, slope of the line, and then BB, it's going to be Y intercept. So can I ask you a favor? Just read about this, that link that I shared with you. I know you are going to understand and you are going to get more explanations compared to what I have given you, and you are going to understand it deep. You see, for them, they give clear explanations. And I know I tried, but I can't be the best as analytics video for these explanations. So try to open it. This is where you are going to get everything you might know about. You can even share this link with your colleagues on WhatsApp, and they are going to benefit from it. So there are some even practical exercise you can just check on it, right? Are you able to open the link? The second link I shared for analytics.
Medramina, I have a question that stick with me since a very long time,
Mhm.
and I wanted to say that about linear regression. I read two books about it, but
Mhm.
there's something that I still cannot understand today, and I decided to wait until we had this lesson about linear regression that maybe Medramina might help me.
Okay.
Is about the in that simple formula. Even this website showed the y equal to m times x plus b.
Mhm.
First, I wanted to know, like, is this b equivalent to saying, is it the same as saying it that the b is bias? Is that
Yes, it's
bias?
bias. Yes.
Okay. So if it is bias, how do we, like, I don't know, estimate or something, or give the value of bias?
Yeah, that is a good question. I wasn't expecting such, but Raj, thank you for asking that. Yeah. As I said, yeah, I was for sure I wasn't expecting such a question. So as I
No.
said, but thank you for that. Um, so as I said, like to understand the linear regression, it's more I wanted to check out love. Yeah. They to just understand more of linear regression, we have to understand that most of the time it's going to give you the prediction, it's going to predict the result, the output, but the output always are going to be not 100% correct, but are going to be close to the correct answer. So the reason why we say that it's not going to be 100 correct, it's because as we said, for example, if you are going to use this graph, like this is a group of variables that we are looking for, and then yet we are going to use linear regression to predict the clustering. So if you use other technique, you can use other technique which might be able to just group this. Sorry. We might use techniques which can just group these variables and then get 100% correct output, right? Nothing is going to be missing. For example, clustering, for example, classification can just do it. But with linear regression, it's this method is going to just be straight, try to give you the answer which is a bit closer to the ones you are looking for. So if you check this independent one are going to be the ones we do have the input value which is going to be dependent sorry, in the input value are going to be the ones for the X. We are going to have dependent and independent, the ones output and input. So the input value are going to be independent. So if you have this is the entire dataset. That is how dataset or variables that you are having, and then yet you predict you have this. These are the result that you are getting. I can say this. These are the missing ones. The worst one we do have, the ones which has been lost. So the reason why we are going to use bias, it's because we are just trying to target. For example, if I want to reach to you, I can reach to Cindy. It's an example. So I can ask Cindy, can I get to Raj? Because I have seen you are closer to Raj. You might know something related to Raj. Cindy might help me to just reach to you, or Cindy might show me a way. That is why we are going to be using bias. So the bias are going to be as a way to reach to the I can say to the predictions, to the right answer that we are looking for, even though it's not correct, or it's not straight to going to reach to the final result that we are looking for. So sometimes it might you might be lucky enough. Cindy might say, okay, you just get his number and then call him. I can just call you and then you can pick it. That is, it can happen. Or I might call you and then you didn't respond. That is true or false. It might happen. So that's why we use bias, because we are not sure if it's going to pass or not. So we predict based on the target that we are having, the inputs that we are having, and also the based on the output that we are going to have. So if you want to have the clear output, that's why we are going to be adding those functions that we've seen, steepest descent. We are going to be checking it. We are going to use theta just to be able to be closer to the answer. But if you use this straight line, either by lucky you can just get the answer, but if you try to go deep and then add more function to it, you can get the correct answer. So it doesn't mean that it's not going to be always the right answer, but sometimes depends on which formula, which function that you've used, you might get to the correct answer. So bias is going to be there for you to get to the correct answer. It's not always to be like just showing something which is like I can say which is not following the rules in that way. I don't know if it's correct, but it might take you to the right way, or to the way you might be able to reach to your target. That's why we've seen that you can use estimation, you can use steepest descent method. There are many mean squared error. We've seen it, how to use it. So there are many things you can use for you to get to the closer answer. So I think that is that's the answer I can give you by now. But the more you work on this, you can see, like for example, if you check here for the best value for or bias 1 to 2, it's going to be checking like we do have y output and x as input, independent and dependent. So if you check, for example, this is the clusters that we are having to this one. So but if they try to apply the bias, they are trying to check which might be the next to this one to this one, this one to this one, this one to this one. And then if you check, they are going to find like the distance. You see, the last distance is going to be the highest one, is going to be this. But if they check the second distance, is going to be this. If they do the slope, this is where it's going to be matching. And then once you check the intercept we've seen that it's going to be the difference between to the mean squared error. So you see, this is what we are having, and then the bias is going to be upright. So that is what I can say by now. But
mentor,
yes,
I think I understood, because it is also related to the fact of finding the optimal
yeah,
point, no? So
yes,
when we are close to the optimal point, we we kind of like automatically get the slope of the graph to be uh, to have that function of the y equals to a times x plus the bias.
yeah,
And the bias, I think it appears kind of automatically, somehow, I
yeah.
think.
It's going
And
to be like
with
more like that. Yeah,
yeah, and with the explanation that you gave, the example, no, that you gave, I think it really like relates to it. Yeah,
yeah.
yeah, I think I understood.
Okay, that sounds good. And thank you for asking questions. I really appreciate. So, do we have other questions? Sorry for that. So, if we don't have other questions, so I really like to appreciate for those of you who joined, and I want to give you a message and then just share it with your colleagues. So it's not um it's not good. So most of your colleagues are not attending, and then they are not giving the some of them, not all of them, they are giving unclear reasons why they are not attending the class, which is so bad. So if they are not willing to continue with the classes, so just ask them like to let me know in advance, because if they spend the next week without attending the session, I will just cancel their subscription, which is not what I'm looking for. I really want all of you to just attend the class and also finish the course, and then reach your goal. Your goal was to be an AI data engineer in the end. So please don't stop in the middle. Just keep thriving, keep just pushing. Don't allow external circumstances to overtake you or drowns your energy to not feeling like you really want to join, but just keep pushing. For those of you who have been attending, I really appreciate you. But if you feel like you are no longer interested in the class, it's okay. It's still okay. You can just let me know. I can just cancel your subscription, and then we can keep up with the ones who are still committed. Yeah, that is what I wanted to tell you. And also rate your colleagues know, the ones you have contact, so you can just pass the message. And thank you for doing that. Thank you very much. If you are going to do it, I really appreciate you. And I wish you all to have a nice weekend ahead. And try to open the shared link, try to read deeper, and then try to do um, many researches, try to dig deep. You are going to just become better. So I wish you all to have a nice weekend. have a nice evening, and see you on Tuesday, and take care. Yeah, thank you.
Thank you, Madam Amin,
Yeah,
and have a good weekend.
yeah, thank you.